Terex collecting information about prices in Y million. So this is prices, and that's distances. And 10 miles, and the data's been summarized. That's quite nice. We've got to work out the product moment correlation coefficient. We've got to work out the regression line of Y on X. So I need the formula sheet. So I'm going to paste in the formulas here. So the first thing we need to work out is R. So it's one of these, and the formulas of the data's been summarized. So I don't want to use this one, so I'm going to cross this one out. And I could use this, but I just find that more confusing. So I like using these ones here and then using the information up here to work it out. So it's SXY, which is the bottom one here. I haven't been given the data like that, so I'll get rid of that one and just use this one here. So in terms of what we got, SXY is the sum of XY, which is 241, minus the sum of X, which is 360, times by the sum of Y, which is 6.8, divide by N, which is 8, and that equals negative 65. And then I'll fill in the other ones, following the same things up here. But obviously not using the middle one, using the N formula. And having worked out the numbers separately here, I can work out what R is, and using the formula SXY, so R equals minus 65 over, that's a square root of SXX, which is 4,200, times by SYY, which is 1.1, and that equals minus 0.956296, which equals minus 0.956 to three significant figures. So that's done the first part. State what this says. So for part 2, it says that as the distance increases, the price drops. Because as one goes up, the other goes down. Negative correlation. Part 3, Terry decides to recalculate the value of R with house prices measured in hundreds of thousands rather than millions. State what effect? Well, they have no effect at all because the scaling doesn't matter. So what effect? None. Full stop. And state, haven't got anything to do. Part 4, calculate the regression line of Y on X. That's the nice one. So I haven't got to replace Y's with X's. And so that's Y on X is Y equals A plus BX. So Y equals A plus BX. And I need to work out what A and B are. The formula sheet says that A equals Y bar minus B X bar. And therefore I need to work out B before I can work out what A is. So B, I've got the gain, the formulas here. That's the, I don't want that one, so I'll get rid of that one. I want SXY over SXX. So I know that B equals minus 65 over 4,200, which equals minus 0.0154761.9. Okay, it goes on like that. I now know I can work out what A equals, because A equals Y bar minus B X bar. So A equals Y bar, it's the sum of the Y's divided by how many are. Take away B, which is minus 0.0154761.9, the answer. So that's minus B times by X bar, which is total of the X's divided by how many are. And that says that A equals 1.546428.5. And so therefore we get Y equals 1.546 minus 0.01547x, or Y equals 1.55 minus 0.0155x, to 3 significant figures. Let's work that out just using the formula sheet. On the last part, 5, I'm showing the last part in a different colour. Not because it's more important, but it's there. Explain why the regression line of y on x rather than x on y should be used for estimating a value of x from a given value of y. Well, that's unusual because normally if you weren't working out a value for x given y, you'd use a regression line of x on y or x based on y. But in this case here, the distance was actually chosen at 10 miles or 20 miles or 30 miles, and therefore we've got x is the controlled variable. And if it's controlled variable, then you always do the y on x, regardless of which one you're working out. So the word we're looking for is controlled variable. And that's question 5 done.